Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 11th, 2025, and we're looking at an ICLR conference paper, Tractable Multi-Agent Reinforcement Learning Through Behavioral Economics, published just over 3.5 months ago. This paper tackles a tough problem in multi-agent reinforcement learning, or MAI agents learning together. Finding ideal strategies, like a Nash equilibrium where no one gains by changing tactics alone, is often very hard. So this research adds human-like traits, risk aversion, agents avoiding risky outcomes, and bounded rationality, agents not being perfectly optimal. This leads to a new type of solvable game outcome, risk-averse quantal response equilibria, or RQE. Alright, so to see how these risk-averse quantal response equilibria work in practice, Figure 1 here presents two plots. They use different penalty functions, like Kullback-Leibler divergence, or KL divergence, a method to quantify risk, and different regularizers, which smooth agent choices, reflecting bounded rationality. The shaded blue area in each plot defines a tractable regime, a zone where these risk-averse quantal response equilibria can be calculated efficiently, based on specific risk and rationality settings. The markers show actual human play. Crucially, these data points largely fall within this blue tractable region, suggesting these equilibria capture human-like decisions while remaining solvable. Building on that idea of capturing human-like decisions, Figure 2 then visualizes these concepts in a simulated environment called the cliff walk. We see two agents, each with a goal, navigating a grid with dangerous cliff areas, those black squares. The key here is Agent 2's policy, essentially its strategy for choosing actions. On the left, with higher risk aversion, Agent 2 takes a longer, safer route. But on the right, being less risk-averse, it opts for a shorter, riskier path, demonstrating how these behavioral parameters directly shape the agent's choices and the resulting risk-averse quantal response equilibria. So the cliff walk experiment really drives home how these behavioral economic ideas, risk aversion and bounded rationality, directly influence agent strategies. The key takeaway is that by building these human-like traits into AI agents, researchers created risk-averse quantal response equilibria. These are great at capturing human-like decisions and are computationally tractable, meaning they can be calculated efficiently. This offers a solid foundation for more practical multi-agent reinforcement learning algorithms. Well, that's all for this paper. Thanks for tuning in to the AI Research Roundup. I'm Alex. Catch you next time.